Welcome to video lecture. Myself Ashwini R.K., Assistant Professor, Civil Department, Rohini College of Engineering and Technology. Today we are going to see about major and minor losses of flow in pipes. Major losses. The major losses of energy are due to friction, which are considerable, hence it is called as major losses. It is determined by Darcy's-Weisbach formula and Chessie's formula. The head loss due to friction is denoted by HF. Chessie's formula, V is equal to C root of Mi, where V is the velocity of flow in meter per second, C is the Chessie's constant, and I is the loss of head per unit length of pipe, that is HF by L. M is the hydraulic mean depth, that is area of flow by perimeter equal to A by P. M is D by 4 for pipe flow. Darcy-Weisbach formula, that is HF is equal to 4FL V² by 2GD, where HF is the loss of head due to friction in meter of fluid. F is the coefficient of friction. The coefficient of friction is a function of Reynolds number, that is Ra. If Ra is less than 2000, that is laminar flow. If Ra is greater than 4000, that is turbulent flow. L represents the length of pipe in meter. V is the velocity of flow in meter per second. D is the diameter of pipe in meter. Minor losses. The losses due to disturbance in the flow pattern or due to change in the velocity are called as minor losses. These losses may occur due to sudden change in area of flow and direction of flow. These losses are less as compared to major losses. The minor losses of head includes the following cases: loss of head due to sudden enlargement, loss of head due to sudden contraction, loss of head at entrance of a pipe, loss of head at exit of a pipe, loss of head due to bends, loss of head in various pipe fittings, loss of head due to obstruction. Loss of head due to sudden enlargement. Here the figure represents the pipe in which the fluid experiences sudden enlargement. Here, the head loss occurs due to separation of flow at the periphery of the smaller pipe, which lead to eddying motion in the corner region. The equation gives a head loss due to sudden expansion, that is H is equal to V1 minus V² divided by 2G, where V1 is the velocity of fluid at section 1,1 and V2 is the velocity of the fluid at section 2,2. Loss of head due to sudden contraction. The figure represents a pipe in which the fluid experiences sudden contraction. The streamlines are converging from section 1,1 to section CC. The head loss occurs only after the vena contracta CC. This is because the flow up to this section is accelerating and the boundary layer separation does not occur. Using Bernoulli's equation, the continuity and momentum equation at section 1,1 and 2,2, it can be proved that the head loss due to sudden contraction is HC is equal to 1 by Cc minus 1 the whole square V2 square by 2G, where V2 is the velocity of fluid at section 2,2 and Cc is the coefficient of contraction, that is equal to AC by A2. If Cc is not given, Hc is equal to 0.5 V square by 2G. Loss of head at the entrance of a pipe. The loss of head at the entrance of the pipe is similar in case 2, loss of head due to sudden contraction. As there is an abrupt reduction in the area from an area of reservoir to the area of a pipe, the loss of head is caused mainly by the turbulence created by the sudden enlargement of the jet after it has passed through vena contracta. That is, H is equal to 0.5 V² by 2G. Loss of head at the exit of pipe. When the fluid flow, the pipe enters into a relatively larger reservoir, the entire velocity is dissipated. If V is the velocity of the fluid in a pipe, the head loss at the exit is given by H is equal to V² by 2G. Loss of head due to bend. The loss of head in bends provided in the pipe may be expressed as H is equal to K into V² by 2G, where V is the mean velocity of the flowing fluid and K is the coefficient of bend. and it depends upon the angle of bend, radius of curvature and diameter of the pipe. Loss of head in various pipe fittings. Pipe fittings in a pipe system causes obstruction to flow and loss of head occurs. The loss of head may be expressed as H is equal to K into V square by 2G, where K is the coefficient of pipe fitting. Various pipe fittings shown in the following figures: bent, T-junction, V-junction, partially closed valve. Loss of head due to obstruction. Loss of head due to obstruction. The loss of head due to obstruction in a pipe takes place due to reduction in the cross-sectional area of the pipe by the presence of obstruction, which is followed by an abrupt enlargement of the streamlines beyond the obstruction, as shown in the figure. HO is equal to 1 by Cc into A minus A naught minus 1 the whole power to V square by 2G, where V is the velocity of the fluid in the pipe, AO is the maximum area of obstruction, A is the area of the pipe, HO is the head loss due to obstruction. Thank you.